I think we're back for our next session, which will be the policy section of the conference, starting with Sonja Chavez from Upper Gunnison River Water Conservancy District. The Upper Gunnison River Water Conservancy District was established in 1959 by taxpayers as they voted to conserve, protect, and defend waters within the Upper Gunnison River Basin. Upper Gunnison works closely with the needs of both the land and the residents of the Upper Gunnison Basin to ensure everybody's water needs are met. Sonja Chavez is the general manager of the Conservancy District and is an expert in water quality, water resource management, policy, and planning. We are honored to have Upper Gunnison River Water Conservancy District sponsor the conference this year, and we are glad to have Sonja Chavez join us today. So without further ado, I'll hand it over to her.
Great, thanks, Max. I'm going to take a moment here to try to share my screen. All right, can you all see it?
We cannot see it yet, no.
Okay. Let me try it one more time. Oh, here we go.
Excellent. We can see it now.
Okay, great. All right, so thanks for having me here today with you this afternoon. Again, I'm Sonja Chavez, the General Manager of the Upper Gunnison River Water Conservancy District. I've just joined the district in December of 2019, but have lived in Gunnison for the past 17 years and raised a family here. So when Max contacted me to talk with all of you and engage in a dialogue about water resiliency, he asked me to talk a little bit about efforts of the Upper Gunnison to improve resiliency in the basin. So I thought I'd kind of take an approach that kind of looked a little bit, you know, we've done a lot of things with regard to the policy side, but maybe focusing a little bit more on the technology. So I hope that's okay. And with that, I will get started here. So I'm not sure how many of you may be non-locals, but I thought I would just kind of set the stage by starting out with showing you where the Upper Gunnison District is located within Colorado. So here is the state of Colorado, in this area that's in black right here is the Upper Gunnison River Water Conservancy District in our boundary line. This is a blowout of that section, and what you can see here is that we have a couple of large reservoirs, Blue Mesa being the largest reservoir both in the basin and within the state of Colorado, and then Taylor River Basin or Taylor Reservoir is up here. This is the Tamichi Basin, this is the Lake Fork, the Savoya, and up here is the East and the Ohio Basin. And so you start out right here, here's where the Gunnison River main stem starts, and then it flows into Blue Mesa. So anyway, the Upper Gunnison District was established in 1959 pursuant to the Water Conservancy Act. Our original purpose was to act as a legal entity dealing with reclamation for the construction and operation of the Upper Gunnison Project. Today our mission has evolved a little bit because the Upper Gunnison Project never happened, and so we primarily support agricultural, municipal, environmental, and recreational uses within the basin. We provide financial, legal, political, and technical and engineering support to our water users, and we are the primary entity representing water users of our basin in negotiation with federal, state, regional, and local entities. We have several major accomplishments, but I'll highlight a couple that many locals will be familiar with, and that's the 1975 Taylor Park Reservoir Operations and Storage Exchange Agreement, the Taylor Park Reservoir Second Fill Decree. We've opposed transbasin diversions. Many of you may have heard of the Union Park legal battle that happened. And we are the last subbasin in Colorado, and we are the only subbasin in Colorado that does not have a transbasin diversion, which is an interesting point. We've also successfully negotiated the Black Canyon Federal Reserve water rights settlement. We have recreation in-channel diversion water rights at the Gunnison River Whitewater Park. And we also provide augmentation water through the Meridian Lake Reservoir Project and the Lake San Cristobal Project, which we help manage. So before we jump into my presentation, I thought it was really interesting to take a moment to just reflect on the term resilience. So Webster defines it as an ability to recover from or adjust easily to misfortune or change. With regard to an object, it is the ability of that object to revert to its original size or shape after being stretched, squeezed, or twisted. So a lot of these terms actually represent somewhat how we feel here in the Upper Gunnison Basin and on the western slope. We are at the very headwaters of the Colorado River watershed, and we are and have been a target for trans-mountain diversions. And then even being at the headwaters of the Upper Colorado River Basin, there is the stress and squeeze of having to comply with the Colorado River Compact and to provide all of the snow flow and snowmelt that heads down into the lower basin states. So other things, interesting things, you know, synonyms for resiliency, it's meaning flexible, adaptable, malleable, pliant, and moldable. And then antonyms are unyielding, inflexible, or rigid. So a lot of those terms can represent the different feelings of water users within the basin. You know, and we'll get into some of those, and I'll try to highlight, you know, the feelings and the culture of water here in the basin as I head through my presentation. So with regard to resiliency, and you know, I think it's also important to keep in mind that it's not only resiliency in terms of water supply, but it's also supporting resiliency of our communities that depend so heavily upon our water supply. I thought it was really interesting to hear the comments from Bill Parker and Susan Wyman in the earlier presentations today, and I think it gave you an idea of the cultural connection to water. And I'll talk a little bit more about Bill's comment about how bare ground causes drought in the context of demand management or conserved consumptive use, which is a tool in the toolkit for water users in terms of dealing with drought and a diminishing water supply. And then Susan's comment also about the impact of COVID and the impact it's had not only on her operations in terms of demand, but the comment we heard earlier, even about the run on beef after the COVID pandemic started, and maybe highlighting the importance of local food sources. So that'll go on. Resiliency of the Upper Gunnison District and the Upper Gunnison community is largely founded in our water supply. Not only do we have a great ski area here with Crested Butte Mountain Resort, but we also have many recreational opportunities, both flatwater recreation, whitewater recreation, angling and fishing, whitewater festivals. You know, people come to our area because it is beautiful and it's green, and because there's still, you know, wild rivers that people can visit, and streams, and you know, great hiking and watersheds to take part in. So anything we do in terms of the river, or being able to provide tools to manage our water resources better, I think helps our community in a number of ways, and I'll try to hit on some of those as well. Some of the tools for addressing resiliency include forecasting tools, both with regard to weather forecasting, but also tools that help us to measure the amount of snow and precipitation that we get in our basin, and how that influences what we do as water managers. I'll talk a little bit about irrigation water management and some things that are happening within the basin. I'll talk a little bit about the perspective of demand management from various water users, and then hit upon storage, and then the importance of storage and our Wet Meadows Resiliency Project. So this is a photo of a snowtail site up in the Taylor River subbasin. This snowtail site is really important in terms of helping us determine or measure snowpack. And it's this tower that relays information via telemetry back regarding snow depth. We have various SNOTEL sites throughout the Gunnison Basin. I think we're going to be working on possibly having more. I think our fourth or fifth one is planned for the Cottonwood Basin. But again, a SNOTEL site, if you think about it, it's just a snow depth measurement in one single location. And so obviously it doesn't capture all the variability throughout the Upper Gunnison. So these SNOTEL sites are one means of and a predictive tool for helping to determine how we're going to manage our water and knowing what kind of a water year we're going into. But we also send folks out to actually physically measure the snow depth and to measure the snow water equivalent within the snowpack. And so basically, you know, if you get a snowfall, how much water is in it. SWE information is collected by the Bureau of Land Management, the Upper Gunnison District, our water commissioner, and then we also have volunteers who go with us out in the field. You know, we carry these backpacks with these tubes in them. We put the tube together, drop the tube into the snow, measure how deep that snowpack is, and then we also weigh the contents within that tube to determine how much, and then do a conversion to determine how much water is within that pack. The third piece of information that we're working on collecting over the past couple of years is snow depth via the Airborne Snow Observatory, or ASO. The ASO program is a collaboration with NASA's Jet Propulsion Laboratory. It's an Earth-based mission whereby a Twin Otter aircraft is flown over a watershed or subbasin on a weekly or monthly time step, and it collects data on snow depth and snow melt. It uses an imaging spectrometer and LiDAR to basically measure the snow depth. So light reflectance colors change depending on how deep the snow is, and which the spectrometer picks up. And then LiDAR is really a light detection and ranging method, which is popular. It's a popular remote sensing method, and it's used for measuring the exact distance of an object to the Earth's surface. And so that can also measure snow depth. This is a map of the various areas where we're doing the ASO flights. Here is the Ohio Creek subbasin. This is a water short subbasin typically. This is the East River, and here's Crested Butte right here. This is the Castle Creek and Maroon Bells area, and then here is the Taylor River subbasin where we have Taylor Reservoir. So what we've done through these three different methods, both the SNOTEL, the physical measurement, and the ASO flights, has combined all those different data sources to try to come up with a more refined idea of what we can anticipate with regard to our snowpack and snow melt and the inflow into our various reservoirs. Typically, with just SNOTEL data, you can have up to 25% errors in the prediction for your snowpack on any given year. This is a map showing the results of those ASO flights, and you can see based upon the colors here where the snow is falling within the basin. This is another close-up of the area. Here's Crested Butte here, and here's Crested Butte Mountain Resort up here. And you can see again where that snowpack is falling. And what's also interesting, and what I'll bring to your attention here, is just where you can see areas where avalanches have been occurring within the basin. This is a close-up of that area, and so you can see where the snow is being deposited and falling off of the sides of those really steep hill slopes and where those slides are occurring right here. So not only is it important both for predicting snow, but you can also get some idea of where avalanche-prone areas might be, maybe where we weren't totally familiar with them in the past. The fourth thing that we're doing here in the Upper Gunnison Basin to help with regard to resiliency, with regard to planning and management of water, is we are conducting our own cloud seeding program. And this is just one example. I believe we have 3 in the basin. There's a Taylor Park Dam generator right here. There's the, we have 2, and then we have the Irwin Lodge generator, which is up here in this area, I think right here. So cloud seeding is basically, for those of you who don't know, is where they inject silver iodide into the atmosphere when you have the appropriate conditions, both wind and storms that have enough, that have the right characteristics in order to generate a snow event or help to supplement the snow event. So all these tools are really great, and we're trying to put them together to figure out how we could utilize them more closely. But one of the things we've also been lacking here in the basin is useful weather data. And so this is a photo of, so the Upper Gunnison is exploring the potential development of radar in the Gunnison Basin because much like Alamosa, which their radar is reflected right here, we are within a flat basin surrounded by really steep mountains, and it makes it very hard to predict weather in our area. Radar could be important in planning ASO flights, which need clear, non-cloudy days to obtain data, but it could also be important with regard to implementing our cloud seeding program. There have been a number of events where our cloud seeding projects just haven't resulted in much precipitation, and so we're hoping that with something like this and coordinating the use of radar within the basin that we could improve our cloud seeding efforts. And I know some people may not know there were reports and there were studies in the past that were really inconclusive about the effectiveness of cloud seeding. But there was a study that was just published at the end of 2018 that proved unambiguously that cloud seeding works, and it can increase precipitation by up to 15%, which is significant. Transitioning a little bit here over to other tools in our toolbox, I wanted to talk a little bit about irrigation efficiency. The Upper Gunnison is currently conducting a stream management or watershed management planning process. And along with that, we are looking at conducting more detailed system-wide optimization planning efforts. So instead of looking at a single farm and their irrigation or a single ditch, we want to look more comprehensively at the total ditch system and the total subbasin to find out how we could be making better use of that water, improving infrastructure, or helping with on-farm irrigation system improvements. So this is a photo of a sprinkler demonstration project that was installed in the Ohio Creek subbasin. Sprinklers here in the Upper Gunnison Basin are not so easy or direct to implement. You have to have the right kind of land layout in order to put in a sprinkler system. And you have to have, if you don't have enough fall in your elevation, you can't generate enough pressure to operate a sprinkler system on gravity. And therefore, if you can't operate it on gravity and develop 60 pounds of pressure, you're going to be looking for other means of pumping and providing that pressure. So you either need to have access to three-phase electricity, which is not common or very close to many areas in rural areas like the Upper Gunnison, or you would have to put in some kind of a generator. So given that the Upper Gunnison Basin has a really short growing season, sprinkler systems don't always work out financially for a producer. They are very popular in the Lower Gunnison Basin, where they can get 2 or 3 cuts of alfalfa or irrigate more high-value crops and really work on soil health practices. But again, I think although we have done the demonstration project and we're trying to learn from it, the whole issue regarding irrigation efficiency is kind of an unknown in the Upper Gunnison, because as you become more efficient, right, you're giving your crop exactly what that crop needs. You're not over irrigating. But there is a really unique connection, as Kate Greenberg pointed out, here in the Upper Gunnison Basin between that groundwater surface water interaction. So if we start becoming more efficient, how will that influence that groundwater surface water exchange? And what could that do to the landscape, and not only the landscape, but the people who rely on that groundwater for drinking water sources, for example. The other thing is, that I think Bill Parker from Parker Pastures pointed out was that sprinkler systems may not result in less consumptive use, and in fact will probably drive up your consumptive use, because you're giving that plant exactly what it needs. It's growing well, you're producing more. And in addition, I think as our climate is changing and as our growing season is extending and our temperatures are increasing we will also be driving up our consumptive use. So it's an interesting thing to explore. I don't think that efficiency on a broad scale may be the answer, but it certainly can make sense in areas where you are water short. I wasn't sure today whether anyone was going to talk about the drought contingency planning that's happening within the Colorado River Basin. So I'll touch on it just briefly and just say that, you know, the goal of the Upper Basin Drought Contingency Plan is to reduce or eliminate the probability of Lake Powell reaching its minimum power pool level. Lake Powell is the storage bucket for our Colorado River compact compliance for all of the Upper Basin states. And so it's, if we cannot get water out of Lake Powell and into Lake Mead, so if it drops below that power pool level or the point at which we can move water to Lake Mead, that is an issue for the Upper Basin in terms of Colorado River compact compliance. So what are the basic elements of the Upper Basin Drought Contingency Plan? So there are 3 elements. They include weather modification and phreatophyte removal, and I touched on cloud seeding earlier. And you know, phreatophyte removal is some of the removal of tamarisk along the Colorado River, which is a really thirsty plant and an invasive species. And then the second item is the drought response operations for upstream Colorado River storage project reservoirs. And then the third thing is demand management. The reservoir reoperation involves the potential to release water from 4 dams in the upper Colorado, well, 3 dams in the upper Colorado River Basin, 1 in the lower, to basically satisfy water uses or demand and falling levels at Lake Powell. So we have Flaming Gorge Dam here. Here's Blue Mesa, which is, or the Aspinall unit, which is composed of Blue Mesa Reservoir, Morrow Point Reservoir, and Crystal Reservoir. And then there's the Navajo Dam and Glen Canyon Dam. The third thing, and getting to demand management or conserved consumptive use, demand management is essentially the elimination of the diversion or not diverting water that would normally be consumptive use. So that can take the form of either full fallowing, no diversions, or it can take the form of split season irrigation where you deny a field of water at a specific time during the growing season in order to get a partial crop. Participating in a potential demand management program in Colorado may be a tool in the toolbox for reducing conserved consumptive use, but at what cost to the environment, to the watershed, to the landowner, to the community. In Colorado, water users have agreed that if there is a demand management program, it should be voluntary, temporary, and compensated. The Upper Gunnison is part of a consortium of Western slope water users who are studying demand management, both from the potential multi-year impacts that may occur on productivity and soil health and even positive benefits to water quality. We are studying the direct impacts of a program to landowners directly and their operations, who may participate, the potential cost of compensation, benefits to the environment, to the stream, and also secondary economic impacts that may occur to a community when you are dramatically changing one of your revenue sources within it. So many complex questions associated with demand management, including how we might even get our conserved consumptive use or how we will be able to deliver that water down to Lake Powell, which is referred to as shepherding. This is a photo of a high elevation grass fallowing project that we were doing here in the Gunnison Basin. This photo on the left-hand side is a fallowed field in September. And on the right side is that same irrigated field, but when it's irrigated at the same time of year. And you can see the difference in the vegetation with that. And, you know, a lot of questions that come up with that is that, you know, how does that influence potential fire danger within a basin? How is fallowing influencing the groundwater surface water interaction? What is it doing to your soil health? Bill Parker mentioned previously in his presentation earlier today that, you know, having bare soils is something that leads to drought and climate change. and that it's not necessarily a good thing. So what can you do, and how long should you be doing it? You know, before jumping into a demand management program, I think we need to ask some of the hard questions and do some studies and research, and help provide information to our landowners that will help them make a decision on whether it's the right decision for them. Finally, or one of just kind of coming here to the end of my presentation, I showed you the slides about the Colorado River Storage Project reservoirs, but smaller storage reservoirs are also important in terms of managing your existing water supply. So this is a photo of Meridian Lake, or also called Long Lake, up near Crested Butte. And this is one of the sources for augmentation water for some of the development that's occurring in the Washington Gulch area and some of these areas downstream. You know, so being at the headwaters of the Colorado River Basin, having some smaller storage could be really beneficial in terms of adapting to or managing for those really dry years that we are seeing or have seen in the last 15 years or so. My final tool in the toolbox is the Wet Meadows Resiliency Project. This is a project being done through the Upper Gunnison Basin in partnership with many of the agencies here, including the BLM and Forest Service. We support a full-time coordinator that helps to plan and implement these projects throughout the basin. They are extremely important for maintaining watershed health, capturing and storing and slowly releasing that water. And they are also, these areas, restoration areas, are also critical for the endangered Gunnison sage grouse, which utilizes this type of habitat. So I hope I've given you some food for thought in the areas of strategies to improve resiliency, and some technological innovations, and maybe expanding upon the cultural issue and the cultural connection to water here, as well as economic issues and resiliency of communities. And I'm happy to take any questions, or you can feel free to contact me as well.
Thank you, Sonja. That was great. We have a few minutes for questions. If anybody has them, please put them in the chat and we'll have Sonja address them. I guess as we're waiting for that, I might have a question I wrote down here. Let me see if I can find it.
Okay.
Or actually, Zach Ducher has one right there. He says, has the Upper Gunnison River Water Conservancy District considered using citizen science data collection? If so, in what capacity? And if not, do you see this as something that could happen in the future?
Yeah, I do think that we could use a citizen science data collection if you're talking about things like programs like River Watch, or I know there was a project by an MEM student at Western that was looking at just the various efforts with regard to water data collection throughout the basin, and was I aware of them, and you know, and how we can use that. So yeah, I think we definitely can. And there's going to be a lot of big things going on, I think, up here, not only in terms of the research that's ongoing now, but USGS is also going to be conducting the next generation water observing system up here in the Gunnison. We're going to be a priority basin, so that should provide a lot of really useful data, and we hope to get our community involved.
Excellent. Yes. Rich Strongberg asked if you can provide the link and the name of the study for the cloud seeding information.
Sure. I'll get that to you maybe in your next break.
Yeah, you can enter it in the chat at any time, would be fantastic. Or you can send
Okay.
it to me and I can send it over to Rich as well.
Sounds great.
Yeah, so it looks like we are pretty much out of time for this session.